So our Getting Ready 9, we're going to look at first here, the first topic, looking at the standard form of quadratic equations. And that is given to us right here. It's ax squared plus bx plus c. We are going to choose a, b, and c from a couple of sample equations. Now what we have to keep in mind here is a is not just always the very first number you see. A is the coefficient for the x squared term. B is the coefficient of the x term, no matter where it shows up. C is the constant, the number that has no variable, no matter where it shows up. So in number one, it is nice, neat, standard form. We have all three, A, B, and C. We can see numbers for all of them. So coefficient of x squared is 5. Coefficient of x term is 3, and the constant 6. Number two, sometimes you won't see an a value. Well, there is still an x squared, so we do have an a. It's just not shown, not written there. A is 1. B, the coefficient of the x term is -7, and the constant is 3. Right? In number 3, we only have 2 terms. So obviously one of these is not shown, it's missing here, the a, the b, or the c. Well, I have an x squared term, so it has a coefficient of 6, that's a. B must be the coefficient of the x term. Well, there is no x term, so that means the coefficient of it would be 0. We have no x's, and the constant is -5. Number 4, coefficient of x squared, -3. Coefficient of x, 4, but there is no constant, so my c value is 0. And number 5, back to one that looks nice and neat with a, b, and c all evident and in order. So a is 8, b -5, c -2. All right, now we're going to look at what would we have to do in an equation to force 2 intercepts, 1 intercept, or no intercepts at all. All right, so if you think about a graph, if we had an equation that was in the form just x squared plus p, now what that means is plus p, we just have a vertical translation. There is nothing else. If we're thinking vertex form or standard form, there's only the vertical translation, and that's all. So also, it's important that the x squared here is positive, so it's going to open up. So what type of graph do I need that would open up and still have 2 x-intercepts? Well, it would have to look something like that. So that means it would have to have moved from this parent graph, which we know has a vertex on 0, 0. It would need to have moved down. Okay, so the only way to make it shift down is to put some negative number for p. So you will choose, it just says find a value for p. Any negative number would do. It doesn't have to be a whole number. You can have -2 or -2.7 or -1/3. To have only one x-intercept, well, that only happens, again, it's open up. That only happens if the graph comes down, bumps the x-axis at its vertex, and then shoots back up. So that would have to mean that it doesn't have any vertical translation at all. The p would have to be 0. There is no other number that could work there. And then in order to have no x-intercepts, this parent graph would have to shift up. So in order to shift up above the x-axis, you would have to put some positive value of p there, any positive value. Now, 9, 10, 11 look almost the same, but each of these has a negative sign in front of the x squared. And what that changes about our graph is it automatically makes it an open down, a parabola that, before we shift, looks like this. Now, where do we have to move that to have 2 x-intercepts? Well, it would have to move up here, and in order to shift this blue parabola up, we would have to put a positive value for p, anything positive. In order to have only one x-intercept, it can't shift at all. It would have to stay right here with the vertex at the origin. So P would have to be 0. Nothing else could work. Nothing else will make that happen. And to have no x-intercepts, this blue parabola would have to shift down so that the entire graph was below the x-axis and never touched it. That happens by putting a negative value for P. All right, now we get to graph and then identify the vertex. Look, we have to be accurate with our key points and shape. That means we want to see the vertex and a minimum of 2 points on each side. A minimum. So you need at least 5 total points. All right. X minus 1 squared. Well, from the parent graph, this tells us that we are going to translate right 1 unit. That will make our vertex 1, 0. Since nothing is in front of the parentheses here, though, A remains 1, so it's still going to open up and no dilation. So right 1 for my vertex, and then I have that standard size of the parent graph, which is when we move to the side 1, we go up 1. When we move to the side 2, we go up 4. And I normally like to get one more, but this grid isn't large enough to get 3 and 9 on each side. This one, we are going to have both a horizontal and a vertical translation. There is still open up, no dilation, but this makes us move right 1, and this +1 in the K spot makes us move up 1. So take my vertex from the original 0, 0 to go right 1 and up 1. My vertex is now located at 1, 1. From there, I just put in my normal to the side 1, up 1. To the side 2, up 4. And again, that's all I can fit on this grid. So that'll have to do for us this time. 14. Now we have a little bit of everything. We're still going to open up because this 2 is positive, but it's going to dilate by a factor of 2. All right, which means it's going to get skinnier, thinner. This makes us still move right 1. The +1 out here still moves us up 1. So how does that change what we graph? Our vertex is still right 1, up 1. So same as it was in number 13. But rather than moving to the side 1 space and up 1, I multiply that normal vertical change by 2. So when I go to the side 1, I'll go up 2. When I go to the side 1, up 2. Normally, when I go to the side 2 spaces, I would go up 4. But I'm doubling that 4, so I need to go up 8. So when I go to the side 2, I'm going up 2, 4, 6, 8. 2, 4, 6, 8. So those points are just off the grid. And 15, we are going to go left 3. So remember, when the change is a horizontal shift inside the parentheses here, we go opposite the sign that we're looking at. So we're looking at a plus, we're going to the left. So move left 3, 1, 2, 3. No vertical shift, no dilation, no reflection. So vertex -3, 0. When I go to side 1, up 1. To the side 2, up 4. So number 16, we're keeping the +3 in the parentheses, so that's still going to move us left 3. We're going to add, in addition, we're going to put a -4 after the squared expression, so that will move us down 4 units. but we also have this negative sign in the front, which makes us open down. No dilation, but it is a reflection over the x-axis. So to get to our vertex, we go left 3 and down 4. That puts us at -3, -4 for the vertex. But since we are open down, all that normal motion, movement from the vertex has to be reversed. So I normally go to the side 1 place and go up 1. Now I go to the side 1 and down 1. I normally go to the side 2 and up 4. Now I need to go down 4, which does put us slightly off the grid here. But it's enough to give us an accurate shape. And lastly, at 17, we have a negative sign, which means open down. We have a change to the A value. It's now 0.5, which is going to make this thing wider. A +1 inside these parentheses moves us left 1, and the +4 outside moves us up 4. So to get to the vertex, I'm just interested in my vertical and horizontal shift. That's left 1, up 4. So that puts me at -1, 4 for my vertex. Now, for my surrounding points, I normally, when I go to the side 1, I would go up 1 space. I'm multiplying that by -1/2. So when I go to the side 1, I'm going down 1/2. Instead of going to the side 2 and up 4, I'm going to go to the side 2 and down half of that, which is down 2. Okay, I can do that again. I got plenty of room on this one since it's wider. My normal shape of a parent graph is when we go to the side 3 spaces, we should go up 9. Well, this multiplied by -1/2 means go to the side 3 and down 2, 4.5. Side 3 down to 4.5. I could even go another one. Normally, to the side 4 spaces would put me up 16. Multiply that 16 by -1/2, I'm going down 8. So 2, 4, down 2, 4, 6, 8. All right, so I can have a really, really accurate graph on this one. Since it got wider, it allows me to fit more points on this grid. And our last section here, we're going to look at a table, try to identify where the vertex is. That should lead us to the line of symmetry. We should be able to tell how many x-intercepts based on whether it's open up or open down and where it shifted. And then would that vertex be a maximum or a minimum? So in our first one, we're looking for symmetry around the vertex. So it happens here. Notice these values, these y values are decreasing, decreasing, decreasing till they hit -6, and then they go back up with the same values we saw approaching the -6. So my vertex is 0, -6, making my line of symmetry x equals the x-coordinate here, 0. The x-intercepts, now granted there are none shown in the table, but if these values go from positive down into the negatives and then start going back up, and they're going to, even if I showed one more box in the table, at +3, the y value would be 3. Somewhere between -2 and -3, somewhere between 2 and 3, I do cross over the x-axis. I do have 2 x-intercepts. Right? Again, that's happening because if your vertex is on 0, -6, and I know it's going open up, it's got to hit 2 places. I don't know where it hits, but it's got to hit twice. And again, if this is a parabola that's open up, it would definitely have a minimum. Okay, number 19. Looking for symmetry around a point, we're going decreasing, 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 and then starts to go back up. So our vertex is at 2, 1. Since those values around the 1 are increasing, they're going up, this graph must look like this. This is 2, 1, and the values around it are increasing on each side. So the line of symmetry is x equals, the x-coordinate is 2. It would not have any x-intercepts because, as you can see, the lowest it ever hits is positive 1, and everything else is above that. This one, again, is a minimum because it's open up. Number 20, I see a vertex here at -5, 7. Now, the values surrounding that 7 are all decreasing. So this time, if my vertex is at -5, 7, and the values around it are decreasing, this parabola must be open down. It has a line of symmetry, x equals -5. It would have to have 2 x-intercepts. I don't know what they are, but somewhere between here and here, it does pass over 0, so 2. And it does this time have a maximum since it is open down. And last one. I see the vertex at -7, -8, because this increased to -8 and then started decreasing again. So if -7, -8 is the vertex and all of the surrounding values are beneath -8, this one must open down. Vertex -7, -8, line of symmetry would have to be x equals the x-coordinate, -7. It would not have any intercepts because it never goes above that -8 for a y value, and the -8 is a maximum.